Alright, what's up guys? This is WWPD on the spring 2022 midterm for CS88. Let's get into it, shall we? For each expression below, write the output displayed by the interactive Python interpreter when the expression is evaluated. The output may have multiple lines. If an error occurs, write error. If any lines are displayed before the error, include those in your output. If a function is returned, write function. Alright. So for part A, we have young and sweet for 17. So if you recall the short circuiting rules, an AND statement will short circuit at the first falsy value, while an OR statement will short circuit at the first truthy value. So when we look at this problem, we have young and sweet, and both are truthy values because they're just strings. So when we see young and sweet, it shouldn't short circuit yet, so we'll continue with our statement. So we have sweet or 17. And because sweet is a truthy value, this OR will short circuit and we will get sweet. Next, we set C equal to this list. We have see that girl, watch that scene, and the indexes are like this. So you may remember that when we use list slicing in this notation, the index on the left is inclusive, while the index on the right is exclusive. So when we slice the list like this, we'll start with the first item, which is that at position 1, and we will go all the way up into position 2, because position 3 is exclusive, so we get that and girl. All right, now we try to get the sixth item inside the list C, but because you can see by this indexing here, we don't have a sixth index, so what will happen here is an error. Okay, now for part D, we set digging equal to this lambda function x, which returns another function lambda and returns 17 plus y. So when we call digging, what will happen is, because we're not actually calling the function, we will just get back function. Because to call the function, we would have to use parentheses and we would have to provide an argument to actually call the function. But because all we're doing is getting what digging is, well, digging is a function, so we will return back a function. Now we're actually calling digging because of these parentheses here, but the problem is that digging takes in an argument x, and because we did not supply an argument inside this function call, we will. Okay, nice. Now for part 4, we're given this function, having the time of your life, which takes in dance and drive. And we have this series of conditionals here, and we'll do things depending on what dance and drive are. So first of all, we have having the time of your life on 88 and false. So let's put these values in here. 88 false. So once again, remember our short circuiting rules from before. And will short circuit on the first falsy value, and or will short circuit on the first truthy value. So we have dance as 88 and drive as false. So looking at this first condition, if dance and drive, then print true. Well, the problem is that this and condition is not satisfied because we need both dance and drive to be true here in order for it to print true. And because drive is false, this condition is not met. So next we go to this if statement. If dance is greater than 0 and drive, then we will print dance. Well, 88, which is dance, is greater than 0, so the first part is correct. But because drive is false, this and statement is not reached and we will not print dance. Next, we will have else if dance is equal to 17, we will print drive. Well, dance is equal to 88, so this statement is not met, so we will just not print drive. And finally, we go into this else case. where we just print queen. So we'll first print queen in all caps. And then we'll go into this final statement here where we just print queen. So we printed out a queen in all capital letters and then a queen in all lowercase letters. All right, on to part G, the final part. Now we run having the time of your life on 17 and not false. So once again, we'll go back up into our function. We'll put in 17 for dance and not false for jive. And you can think about not false as being true, because when we do not, we're essentially calling the opposite of something. So when we call not false, we can just think about it as true. So here we have if dance and jive will print true. Well, dance is 17, which is a truthy value, and jive is true or not false, which we can think about as true, which is a truthy value. And so we will print true. All right, next we go into this next if statement where if dance is greater than 0 and jive, then we will print dance. Well, dance is greater than 0 because 17 is greater than 0, and jive is not false, which is true, and it's a truthy value, so we will print dance. Next, we do not go into this else if or else case because the if case here was satisfied, so we don't need to look at the else if or the else case. And now we will just go down to our final statement, which is print queen. And so we print queen. And yep, that's pretty much it for this problem. See you all in the next one.